Day. Hello, everyone. Welcome to our Deep Dive podcast, where today we'll be reviewing the Qwen-Image technical report published by the Qwen team in August 2025. Are you ready to explore the latest in image generation foundation models?
Absolutely. Qwen-Image has been making waves in the AI community, especially for its advances in complex text rendering and precise image editing. Let's start by summarizing what makes this model stand out.
Great idea. Qwen-Image is part of the Qwen series and is designed to address two major challenges in image generation: complex text rendering, especially for languages like Chinese, and consistent, high-fidelity image editing. The team built a comprehensive data pipeline and adopted a progressive training strategy to tackle these issues.
That's right. The data pipeline includes large-scale data collection, filtering, annotation, synthesis, and balancing. They also use curriculum learning, starting from simple text rendering and moving to more complex, paragraph-level descriptions. This approach significantly enhances the model's native text rendering capabilities.
And it's not just about English. Qwen-Image excels in both alphabetic languages like English and logographic languages like Chinese, which is a huge leap forward. But what about image editing? How does Qwen-Image ensure consistency and quality there?
For image editing, Qwen-Image introduces an improved multitask training paradigm. It incorporates traditional text-to-image, T2I, text-image-to-image, TI2I, and image-to-image, I2I reconstruction tasks. This aligns the latent representations between Qwen 2.5-EL and MMDIT, ensuring both semantic consistency and visual fidelity.
That's impressive. The dual-encoding mechanism is particularly interesting. The original image is fed into both Qwen 2.5-EL and the VAE encoder, extracting semantic and reconstructive representations. This allows the editing module to balance semantic consistency with visual realism.
Exactly. The architecture is built on three core components: a multimodal large language model (MLLM) for feature extraction, a variational autoencoder (VAE) for image tokenization, and a multimodal diffusion transformer (MMDIT) as the backbone diffusion model.
Let's break down each component. First, the MLLM. Qwen-Image uses Qwen 2.5-EL as its feature extraction module. Why did the team choose this model?
There are three main reasons. First, Qwen 2.5-EL's language and visual spaces are already aligned, making it ideal for text-to-image tasks. Second, it retains strong language modeling capabilities. Third, it supports multimodal inputs, enabling a broader range of functionalities, including image editing.
Moving on to the VAE, Qwen-Image adopts a single encoder, dual decoder architecture. This design is compatible with both images and videos, which is forward-thinking considering the future of video models.
Yes, and to enhance reconstruction fidelity, especially for small text and fine-grained details, the decoder is trained on a text-rich corpus, including real-world documents and synthetic paragraphs in both English and Chinese.
The team found that balancing reconstruction loss with perceptual loss reduces grid artifacts, and that fine-tuning only the decoder can significantly improve the rendering of small text. This is crucial for high-quality text rendering in generated images.
Now, let's talk about the multimodal diffusion transformer, or MMDIT. Qwen-Image introduces a novel positional encoding method called multimodal scalable rope, or MS-rope. Can you explain how this works?
Sure. MS-rope treats text inputs as 2D tensors and encodes them along the diagonal of the image grid. This allows for better image resolution scaling and improved text-image alignment, which is essential for complex text rendering tasks.
The architecture is quite robust. According to Table 1 in the report, Qwen-Image's MMDIT backbone has 60 layers and 24 attention heads, with a head size of 128. The VAE encoder and decoder are also highly efficient, with 19M and 25M parameters respectively.
Let's shift gears and discuss the data. The Qwen-Image team collected and annotated billions of image text pairs, focusing on data quality and balanced distribution. The dataset is organized into four primary domains: nature, design, people, and synthetic data.
Nature makes up about 55% of the dataset, covering objects, landscapes, cityscapes, plants, animals, and more. Design is 27%, focusing on structured visual content like posters and user interfaces, which often contain rich textual elements.
The people category is 13%, including portraits, sports, and human activities. Synthetic data is 5%, but it's important to note that this doesn't include images generated by other AI models. Instead, it's data synthesized through controlled text rendering techniques.
The data filtering pipeline is also worth mentioning. It consists of 7 sequential stages, from initial pre-training data curation to high-resolution refinement and multi-scale training. Each stage targets specific aspects of data quality, alignment, and diversity.
For example, Stage 1 removes low-quality or irrelevant images. Stage 2 focuses on image quality enhancement, and Stage 3 improves image-text alignment. Synthetic data is introduced at Stage 4 to enhance text rendering capabilities.
Stage 5 transitions to high-resolution images, Stage 6 balances category representation, and Stage 7 implements balanced multi-scale training. This ensures the model retains general knowledge while adapting to higher resolution inputs.
The annotation pipeline is also innovative. The team uses a capable image captioner to generate both comprehensive image descriptions and structured metadata, such as object attributes, spatial relationships, and verbatim transcriptions of visible text.
This approach supports advanced data curation and provides a solid foundation for training robust image generation models. The data synthesis pipeline is also multi-stage, integrating pure rendering, compositional rendering, and complex rendering strategies.
Pure rendering involves extracting text paragraphs and rendering them onto clean backgrounds. Compositional rendering embeds synthetic text into realistic visual contexts, while complex rendering uses programmatic editing of predefined templates.
This comprehensive data synthesis framework addresses the scarcity and imbalance of textual content in natural image datasets, especially for rare Chinese characters.
Now, let's discuss the training process. Qwen-Image uses a flow-matching training objective, which facilitates stable learning dynamics via ordinary differential equations. The model is trained to predict the target velocity, with the loss function defined as the mean squared error between the predicted and ground truth velocities.
To ensure high throughput and training stability, the team adopts a producer-consumer framework, decoupling data preprocessing from model training. The producer handles data filtering and encoding, while the consumer focuses on distributed model training.
They also use a hybrid parallelism strategy, combining data parallelism and tensor parallelism to efficiently scale training across large GPU clusters. Distributed optimizers are used to alleviate GPU memory pressure.
The training strategy is multi-stage, progressively enhancing data quality, image resolution, and model performance. This includes moving from low to high resolution, integrating textual rendering, refining data quality, balancing data distribution, and augmenting with synthetic data.
Post-training involves supervised fine-tuning and reinforcement learning. Supervised fine-tuning uses a hierarchically organized dataset with meticulous human annotation, guiding the model toward greater realism and finer details.
For reinforcement learning, the team employs direct preference optimization, DPO, and group relative policy optimization, GRPO. DPO is used for large-scale offline preference learning, while GRPO is reserved for fine-grained RL refinement.
The multitask training paradigm extends Qwen-Image's capabilities to instruction-based image editing, novel view synthesis, and computer vision tasks like depth estimation. The model natively supports image inputs, enabling a wide range of multimodal tasks.
Let's move on to the experiments. Qwen-Image is evaluated across multiple public benchmarks, including GenEval, DPG, and 1IG-Bench, for general image generation, as well as G-Edit, Image Edit, and GSO for image editing.
On the DPG benchmark, Qwen-Image achieves the highest overall score on both the Chinese and English tracks, ranking first in alignment and text categories.
For text rendering, Qwen-Image performs exceptionally well on both English and Chinese benchmarks. On the CVT-G2K benchmark for English, it achieves performance comparable to state-of-the-art models. On the Chinese word benchmark, it attains the highest rendering accuracy across all difficulty tiers.
On long text bench, Qwen-Image attains the highest accuracy on long Chinese text and the second highest on long English text, illustrating its superior long text rendering capability.
For image editing, Qwen-Image ranks at the top of both the English and Chinese leaderboards on the G-Edit bench, demonstrating strong editing capability and generalization to multilingual user instructions.
On the image edit benchmark, Qwen-Image ranks highest overall, closely followed by GPT-Image 1 High, showing competitive instruction-based editing performance.
In novel view synthesis, Qwen-Image achieves state-of-the-art performance, outperforming dedicated 3D models in several challenging rendering scenarios.
For depth estimation, Qwen-Image achieves highly competitive results among diffusion-based models, performing on par with state-of-the-art models across multiple benchmarks.
The qualitative results are equally impressive. Qwen-Image delivers more precise reconstructions for images with small texts, excels in English and Chinese text rendering, and accurately models multi-object and spatial relationships.
In image editing, Qwen-Image demonstrates superior consistency in unmodified regions, better style alignment for newly generated objects, and accurate pose manipulation while preserving fine details.
Chained editing and novel view synthesis further showcase Qwen-Image's ability to maintain global consistency and semantic coherence in complex editing tasks.
The conclusion of the paper highlights Qwen-Image's major advancements in complex text rendering and precise image editing. The model's comprehensive data pipeline and progressive curriculum learning strategy substantially improve its capability to render intricate text within generated images.
The improved multitask training paradigm and dual-encoding mechanism significantly enhance the consistency and quality of image editing, improving both semantic coherence and visual fidelity.
Extensive experiments on public benchmarks consistently demonstrate the state-of-the-art performance of Qwen-Image across a wide range of image generation and editing tasks.
The broader implications are profound. Qwen-Image redefines priorities in generative modeling, emphasizing precise alignment between text and image, especially in text rendering.
The model points toward a future where generative models do not merely produce images, but genuinely understand them, and understanding models achieve comprehension through intrinsic generative processes.
Qwen-Image's contributions extend beyond technical benchmarks, challenging the community to rethink the roles of generative models in perception, interface design, and cognitive modeling.
By emphasizing complex text rendering and addressing classical understanding tasks through the lens of image editing, Qwen-Image paves the way for truly interactive, intuitive, and intelligent multimodal agents.
In summary, Qwen-Image is more than a state-of-the-art image generation model. It represents a paradigm shift in how we conceptualize and build multimodal foundation models.
That wraps up our review of the Qwen-Image technical report. We hope you enjoyed this deep dive into one of the most exciting developments in AI image generation.
Thank you for joining us. To summarize, Qwen-Image sets a new standard in image generation and editing, with exceptional capabilities in complex text rendering, semantic alignment, and multimodal understanding, marking a significant milestone in the evolution of large foundation models.
Stay tuned for our next episode, where we'll continue to explore the cutting edge of AI research. Goodbye.
Goodbye, everyone.